And if you ever go to Hawaii, the big island, you can actually go tour the volcano over here, and they have a museum, and you can see this is a very active volcano. In fact, this is one of the most active volcanoes on the earth. Now, this is not the kind of volcano that erupts and spews out ash. It's what's called a shield volcano. But it spews out lava, and the lava just flows down the hill and flows until it hits the ocean and creates new land. Hawaii is the biggest of the islands because it's right over the hot spot still. And so it's still pushing up new land. Once the plate moves and it moves off and it creates a new island, then this will start to erode away and get smaller and smaller over time. This has been going on for hundreds of millions of years, and that's why there's a whole string of islands. And you can see that right here. Here is Hawaii, the big island. Here's the other ones, this is Oahu, and where Honolulu is where most people go. And then, but if you look under the water, look at all these islands. It goes all the way up here. This is Midway Island. Really important in World War II because it's midway, it's halfway between Japan and Hawaii. And so it became critical for military bases there. And so there was big battles over Midway. But you can see that the continental plate has been moving like this for a long, long time. The Pacific plate has. The hot spot has stayed in the same spot, but the plate keeps moving over it. If you go from the bottom of the ocean, you measure to the bottom of the ocean to the top of Hawaii, its highest point, it's actually taller than Mount Everest. Technically, it would be the tallest mountain in the world. But from sea level, it's not. It's just, we should say, the largest mountain in the world. But it has to start all the way from the bottom of the ocean. And that's called a hotspot. Now, hotspots are interesting because we see these volcanic hotspots on Venus and on Mars, but we don't see the plate tectonic activity that we see on the Earth. All right, let's talk about impact craters on the Earth. Impact cratering on the Earth. This is Barringer Meteor Crater in Arizona. It occurred about 50,000 years ago. An object came in, hit in northern Arizona. You can go visit it. It's a museum. You drive up and you can go look at it. I've been there. It's very cool. And the crater's still there. The crater, I think, is about 1.5 miles across. And so the object they think hit was about 100 feet, 200 feet across. Remember, it's about 10 times that size to create that large of crater. Now, it happened 50,000 years ago, so there were no humans that were in the area. But it would have created this fireball that went out and wiped out, cleared the area of trees and everything around it too. But that's one of the best preserved impact craters. Now, there's many more impact craters on the Earth. All these red dots signify impact crater sites. A lot of them are below the ground. You can't even see it on the surface because we have a lot of wind and rain and erosion, and we have continental plates. Our impact craters seem to go away. Where you look at the moon and it's completely covered, but at least the highlands are all covered in impact. Earth probably got as many impacts or even more because we're larger. But over time, our land keeps reforming and they go away. A lot of these are found. This one's in Australia. You see this nice ring here. A lot of them are found because of searching for oil. When they search for oil, they look under the ground and they map the rocks and they find these circular compressed rock structures. That occurs when an impact hits, and they realize that was an ancient impact crater. Okay? It also helps if you're in the middle of a desert, like this is all desert in Australia, because then it doesn't erode away as fast and you can see more impact craters in those regions. In the jungles and stuff, tough to find impact craters. There are probably just as many there. And you don't see as many under the oceans. Well, we don't look as much under the oceans. All right. This is not an impact crater, but this is a place called Tunguska, Siberia. This is what we call an airburst. And in this case, what happened was an object came into the Earth's atmosphere. We think it probably was a comet. And it was over northern Siberia, and it blew up in the air. It exploded. Why did it explode? Well, comets are made of ice, water ice. And so as it hits the atmosphere, it gets really, really hot. All that water inside turns to steam, and that steam will then blow it apart, and you have this massive explosion. Well, this is really remote in Siberia. I mean, it took Siberia. They know it occurred. It occurred in 1908. But it took till like 1920 something before anybody got back there. They had to get a huge expedition with horses. There were no roads, no way to get back there until they finally got back there. When they got back there, this is what they found. All the trees outward from the central location were all flattened. So all the trees were flattened outward from the central location. And this was not a small thing. This was for like several hundred square miles of trees just flattened. But the trees right at the center actually were still standing. They were still straight up and down, but all the trees around it were all flattened. That's why we know it blew up in the air, because then the pressure from the explosion went straight down and stripped off all the limbs, but the trees were still standing because they didn't get pushed sideways. All right, that happened in 1908, so that was an object that entered the atmosphere over Siberia. I mean, if this same object entered over a populated city, it would have just destroyed the whole city. It would just be gone. Okay? Luckily, it happened in Siberia, a very remote location. And then the most famous impact crater is this one here. It's called the Chicxulub crater. This one happened about 65 million years ago. This one is the one we think wiped out the dinosaurs. Why? Well, there's three pieces of evidence for this. First of all, we have the crater. The crater is right here. So in the Gulf of Mexico, they do a lot of drilling, offshore drilling for oil. They were looking for that, and so they were mapping the underground rock structure, and they saw this nice circle with a central peak here. They're like, okay, that was definitely an impact crater. And then they can date it by dating the rocks, and they realized it was 65 million years ago. That is when the dinosaurs all ended. So if you look at the fossil record, dinosaurs existed from about 200 some million years ago to 65 million years ago, and then they stopped everywhere on the planet. Nobody has found a fossil of a dinosaur after that, a large dinosaur. Some of the smaller bird-like ones probably turned into birds. Started out as dinosaurs that turned into birds. But any large fossil, dinosaur was wiped out at exactly the same time all over the planet, even though all the continents were separated. If it was a disease or something, then they would have wiped them out like on Africa, but North America would have been fine because there was no interaction between the two. But it wiped them out all over the earth. And three, we have the KT boundary. This is the boundary between the Cretaceous, which is the K, and the Tertiary geological eras. What you care about is in that layer, all over the earth, between these boundaries, so this is the older rock down here, this is the newer rock here, there's this layer of black dust. You see that? That layer of black dust contains iridium in high amounts. Iridium is a rare earth element. You don't find it